Reinforcement details of a simply supported two-way slab whose corners are free to lift with the following specifications and prepare the bar bending schedule. Number 1. Size of the room is 4 meter by 5 meter. Overall depth of slab is 120 mm. Slab is simply supported and corners are free to lift. Number 4. Bearings on wall is 230 mm. Number 5. Shorter span reinforcement. 12 mm dia at 160 mm center to center. Alternate bars are cranked at a distance of 400 mm from the face of the support. Next one. Longer span reinforcement. 10 mm dia at 150 mm center to center. Alternate bars are cranked at a distance of 500 mm from the face of the support. Number 7. Top clear cover and bottom clear cover is 20 mm. All side covers are 25 mm. 8. Grade of the concrete is M20 and grade of steel is Fe415. 9. Anchor bars along shorter span and longer span are 6 numbers of 8 mm diameter. Draw the following to a suitable scale. A. Bottom plan of the reinforcement. B. Top plan of the reinforcement. C. Cross section along the shorter span. D. Cross section along the longer span. First, prepare the schedule of reinforcement by calculating the length of main straight bar, main cranked bar and straight hanger bar along the different spans. Length of main straight bar. So A is the main straight bar. We have to calculate length of main straight bar in shorter span. So along the shorter span. So it is LMSS. Length of main straight bar along shorter span is equal to, so this is the cross section of the slab in shorter span. These are the supports on both sides. The cover on both sides is 25 mm. And alternative crank bars are provided at a distance of this portion is at a distance of 400 on both sides of the supports. This is 400 from this support. Similarly on this side also main bars and the cranked bars are provided alternatively on the shorter span as well as on the longer span. See, the arrangement is, this is the laying of main bars. The spacing between the two crank bars is 2 times actual spacing. Similarly, for main straight bars, spacing is equal to 2 into actual spacing. And there are 3 hanger bars are provided to support this crank on this side, and 3 are on this side. Main diameter of straight bar is 12 mm at 160 center to center, but we have to provide 2 into 160, 320 mm. Similarly, for alternate cranked bars, the spacing is 2 into 160, 320 mm. The length of main straight bar is equal to, this is the clear span, 4000 mm. 4 meters means 4000 mm. Width of bearing is equal to 230 mm on either side of the slab. 230. These are the end covers, 25 mm, 25 mm. Total length of main straight bar is equal to 4000 plus 230 plus 230 minus 25 minus 25. Therefore, length of main straight bar in shortest span is equal to 4410 mm. Now calculate the number of bars required to place along this shorter span. Number of main straight bars along shorter span is equal to total length of slab. See, this is the slab, this is the shorter direction, this is the longer direction. We are providing this straight bar like this, so we have to get the length in the direction to get the number of stirrups. Total length of slab in longer direction excluding end covers divided by 2 into spacing. See, this is the arrangement of straight bars as well as cranked bars. 2 into spacing given is 1 to 160 mm plus 1. Clear span in the longer direction is 5 meters, that is 5000 mm plus 2 into bearings minus 2 into end covers divided by 2 into 160, 320 plus 1. 17.906 numbers are required, so we can provide 18 numbers. Next one is main cranked bar along the shorter span. LM3S is equal to length of main straight bar in the shorter direction plus 2 into crank allowance. 1 crank allowance is equal to 0.414 times D. D is the vertical depth from the center of reinforcement here to center of reinforcement here. Here D is equal to overall depth 120 minus top cover minus bottom cover, minus 20 and minus dia by 2. So diameter of cranked bar is 12 mm minus dia by 2 minus dia by 2 is equal to 68 mm. Therefore, length of main cranked bar along short span is equal to length of main straight bar, which is equal to 4410 meters plus 2 into crank allowance is 0.414 into D, 68. After calculating, which is equal to 4466.30. So we can make it to 4467 mm. Number of main cranked bars along shorter span is equal to number of main straight bars along shorter span minus 1. So in the plan, this is the shorter span. This is the longer span. Main bar is provided here and alternate main bars are provided like this. In between, This is the cranked bar. So total number of cranked bars are less than 1. Of main straight steel bar. Total number of main straight bars in shorter span is equal to 18. Therefore 7 numbers are required along the shorter span. Now calculate the length of main straight bars along longer span. Length of main straight bars along longer span. LMSL is equal to clear span in longer direction plus 2 into bearing minus 2 into end cover in the longer span. Clear span is equal to 5000 plus 2 into bearing 230 minus 2 into end cover 25 mm. 5410 mm. Number of main straight bars along longer span is equal to total length of slab along in shorter direction excluding end covers divided by 2 times spacing of this main straight bars in longer direction, which is equal to 150 mm plus 1. Total length of slab along shorter direction excluding covers is already calculated, which is equal to 4410 mm. So which comes from clear span plus 2 into 230 minus 2 into 25 divided by 2 into 150 300 plus 1. So this is 15.7. Total number of main straight bars along long spans are 16. Next one is main cranked bars along longer span, which is equal to length of main straight bar along longer span plus 2 into crank allowance. Length of main straight bar in longer span is equal to 5410 plus 2 into crank allowance is 0.414 times D. D is equal to total depth of slab minus 2 into covers. Top cover is 20, bottom cover is 20. Therefore, you can write 2 into 20 minus diameter by 2 minus diameter by 2. Here, main straight bar and cranked bar diameter is 10 mm in the longer span direction. Therefore, length of main cranked bar along longer span is equal to 5467.96 mm. You can write it as 5468 mm. And number of main cranked bars along longer span is equal to number of main straight bars in the longer span direction minus 1. 16 minus 1, which is equal to 15 numbers. Anchor bars or hanger bars along the shorter span. See, these three are the hanger bars and these three are the hanger bars. These are provided like this. So this length is equal to length of the main straight bar along the longer span. Length of main straight bar along the longer span, which is equal to 5410 mm. So number of hanger bars along the shorter span is equal to 3 plus 3. 6 numbers. Next one is anchor bars or hanger bars along the longer span. See, these are the anchor bars provided in the longer span. The length is equal to length of shorter span main steel bar. So length of main straight bar in the shorter span 4410 mm. Similarly, number of hanger bars along longitudinal span is equal to 3 plus 3, 6 numbers. Now prepare the bar bending schedule. So first bar is main straight bar in shorter span, which is A, which is a straight bar. Diameter is 12 mm. Number of bars are 18. Length of one bar is 4.410. Total length is equal to number of bars into length of bar. 18 into 4.41. 79.380. Weight of bar per meter length is equal to 12 square by 162.0.887. Total weight is equal to total length of bar into weight of the bar. 79.38 into 0.887. 70.410. Number 2. Second bar is B, main cranked bar in shorter span, which is a cranks on both sides. Diameter is equal to 12 mm. Number of bars are 70. Length of one bar is equal to 4.467 meters. Total length is equal to 75.939 meters. Weight per meter length of bar is equal to 0.887. Total weight of the bar is equal to 67.357 kgs. Number 3. C bar is the straight bar, main straight bar along the longer span. Diameter is equal to 10. 60 number of bars. 5.41 meter length of a bar. Total length is equal to 86.560. Weight per running meter is equal to 0.616. Total weight is equal to 53.320. Fourth bar is main cranked bar in longer span, which is D. Diameter is equal to 10 mm. Number of bars 15. Length of one bar 5.468. Total length of bar is equal to 82.02. Weight per meter is equal to 0.616. Total weight of the bar is equal to 82.02 into 0.616. 50.524. Next one is E, which is the hanger bar or anchor bar in the shorter span along the shorter span. Diameter of hanger bar is equal to 8 mm. Number of bars are 3 plus 3, 6 numbers. Length of one hanger bar along shorter span is 5.410 meters, total length 32.460 meters, weight per meter length of steel is equal to 8 square by 162.2, 0.394 kg per meter, total weight is equal to 32.46 into 0.394, 12.789 kgs. Last bar is hanger bar along the longer span. Diameter 8 mm, number of bars 6. Total length of hanger bar is equal to length of main straight bar in shorter span, which is 4.410 meters. Total length 6 into 4.41, 26.460 meters. Weight per meter length is equal to 0.394. Total weight is equal to 10.425 kgs. Therefore, total quantity of steel $70.41 plus 67.357 plus 53.32 plus 50.524 plus 12.789 plus 10.425. Total 264.825 kgs.